Solve exponential equations of the form a of x equal to a of k for x. The exponential function that has a variable in an exponent such as 9 to the power of x equal to 27. So property for solving an exponential function: if a is greater than 0 and a is not equal to 1, if a of x, a to the power of x equal to a to the power of y, then we can conclude from that x is equal to y. So if you have an equation, if I can make the base the same number, I can conclude that the exponents are equal to each other. Or vice versa, if I make the exponents the same, then I can conclude from there the base would be the same, equal to each other. So solve an exponential function. Step number 1, each side must have the same base. If the two sides of the equation do not have the same base, express each as a power of the same base if it's possible. Step number 2, simplify exponents if necessary using the rules of exponents. And step number 3, set exponents equal using the property given in the section, and then solve the equation, obtain the step number 3. So let's take a look at the example, see if all that means. Let's take a look at this example. 25 to the power of x is equal to 125. Now, the step number 1 is to see if you can make the base the same. It looks like I can. This is 25. This is 125. Both of these are a factor of 5. Right? 25 would be 5 squared. 125 is 5 cubed. So if I write this as all base 5, left-hand side becomes 5 to the power of 2x. Right-hand side would be 5 to the power of 3. So if the bases are the same, the exponents must be the same. So if I have a to the power of x is equal to a to the power of y, I can conclude from here that x must be equal to y. So the exponents 2x must be the same as 3. Then you can solve for x. You can check the answer, the solution, see if it makes sense. So if I substitute for each x here, 3 over 2, then you can see the right-hand side and left-hand side would be equal to 125. Then the solution would be 3 over 2. So the goal here is to make the base the same where it's possible. Solve the equation 25 to the power of x minus 2 is equal to 125 to the power of x. So in this case, I can write 25 as factor of 5. See, 25 is the same as 5 squared. 125 is the same as 5 cubed. So everywhere I see 25, I'm going to substitute 5 squared for that. Everywhere I see 125, I'm going to substitute 5 cubed. Then looks like the left-hand side I get 5 to the power of 2 times x minus 2. On the right-hand side I get 5 to the power of 3 times x. So 2 times x minus 2 must be equal to 3x. If the base is the same, if I have x to the power of n is equal to x to the power of m, you can conclude from that that n must be equal to m. Now making the base the same, the base is the same, so exponents must be the same. Then I can solve for x now. X would be equal to minus 4. We always want to check the answers if that makes sense. If I substitute for each x minus 4, both sides, make sure that the right number. I can use a calculator to confirm that's true. Then you can say the solution is minus 4. If you want to solve 4 to the power of x equal to 1 over 32. Like the goal here is to make the base the same. So 4, I can write it as 2 squared. 32, same as 2 to the power of 5. Okay, so if I substitute those values here, everywhere I see 4, I can substitute here for this 2 squared. And then I have this x here. Everywhere I see 32, I'm going to substitute 2 to the power of 5. If I want to move this 5 to the top of the fraction, notice that if I have a to the power of minus n, that would be 1 over a to the power of plus n. So how the exponents change sign. So if I want to move this up, it becomes a minus 5. Okay. So again, if the base is the same, the exponent must be the same. So in this case, I can conclude that n must be equal to m. So in this case, I have 2 to the power of 2x, so the 2x must be equal to -5. You can solve for x, substitute the number into the original equation, make sure that makes sense, and then you can confirm the solution is -5 over 2. We're going to solve 3/4 to the power of x equal to 16 over 9. The goal here is to make the base the same. This is 3/4. Can I make 16 over 9 looks like 3/4? Looks like I can, because if I take 3/4, that would be, let's write this as something square, right? Here would be, to the left hand side I have 3/4. The base here is 16 over 9. So if I write 9 is 3 squared, 16 is 4 squared, so looks like 16 over 9 is the same as 4/3 squared, right? But here we have 3/4, here we have 4/3. Remember one property we had, if I have a over b to the power of minus n, that's the same as b over a to the power of plus n. So I can write a reciprocal here by changing the exponent. So this is the same as 3/4 to the power of -2, because we want to force the base to be the same. By doing that, you can use the property that a to the power of n is equal to b to the power of a to the power of m. So the base has to be the same. You can conclude from here that the exponents must be the same. That's what we're going to use. Okay, so we're forcing the base to be the same by using these properties. So from here we can conclude that x must be equal to -2. That's what the exponents are. You can check the answer by substituting for each x minus 2 and confirm that would be the same number, and we can find the result is -2. So we need to make the base the same as each other.